Hello, discrete math fans. What we'd like to do is take a particular input-output table, any table, and design a circuit that will give us that table. So as an example, let's take this input-output table and design a circuit. This is a very fundamental operation in digital logic design. First thing we're going to do is construct a Boolean expression that has this table as its truth table. First, let's take note of which rows have a 1 as the output. Go back and note that the first, fourth, and fifth rows all have an output of 1. All the other outputs are 0. Now, for each row, what we'll do is construct a Boolean expression that'll output a 1 for that particular input combination. Okay, so for example, in row 1, we have inputs of p equals 1, q equals 1, and r equals 1. That's going to give us the expression p and q and r, because that expression yields a 1 if and only if we have that particular input. Now look at row 4. That has an input of p equals 1, q equals 0, r equals 0. That leads us to the expression p and, not q, and, not r. That expression will output a 1 if and only if p is equal to 1, q is equal to 0, and r is equal to 0. And finally, row 5, that has inputs p equals 0, q equals 1, and r equals 1. That's going to lead us to the expression not p and q and r. Again, that expression outputs a 1 if and only if p equals 0, q equals 1, and r equals 1. So what we want is to take any Boolean expression that'll give this table as its truth table, and so we need to have a 1 whenever p and q and r equals 1, or when p and not q and not r equals 1, or when not p and q and r equals 1, and we want an output of 0 otherwise. Well, that leads us pretty obviously to this Boolean expression, is we take all of those ands and then we order them together, because we want a 1 when any one of those is 1. Any Boolean expression in this form is called in disjunctive normal form. It's also called sum of products form. Now, it's going to be a pretty straightforward thing to construct a circuit corresponding to this Boolean expression. When we do so, we're going to take advantage of the multi-input gates that we introduced in the last problem. All right, here it is. This is a circuit that corresponds to the Boolean expression we came up with, and therefore this circuit will have an input-output table corresponding to the table that we gave before. Notice that we have p and q and r here, and then what's going on down here? This and is going to give us p and, not q, and, not r. And then down here for this and, that'll be not p and q and r. And then we take all three of those ands, and then we order them together to get our final result. Notice that how we put this thing together, we're essentially just gluing together a bunch of recognizers. So that's why we discussed recognizers earlier. Now we're piecing that together to create a circuit that will output any particular table. Okay, that's all for now.